Welcome back, everybody. In this section, we're going to be taking a look at DHCP, or the Dynamic Host Configuration Protocol. Now, DHCP is going to be one of those topics that normally the engineer and the systems engineer is going to focus on, because this is normally what end users are going to expect to use for addressing. Expect in the regard of, they were going to need an IP address in order to get somewhere in the network. And in order for that to happen, there's got to be some mechanism, a Dhcp server, to allow that to happen. But that also can be allowed inside of in the enterprise. Whether you receive a dynamic address from the provider, or you don't want to go through and manually provision IP addresses on a particular prefix, or a transit link between two different devices. Normally, you're going to do that statically, but there is the option to do it dynamically. So the Dhcp client could be a router or switch, and you could configure them to do that. So they can either receive or hand out an IP address, or a Dhcp server as well. So I can configure a router or a switch to be able to assign IPs dynamically. I can also use what they call the relay agent. And the relay agent, in a nutshell, is a mechanism that is used from the LAN segment where DTP IP addresses are going to be received from, so end users, things like that. And if the Dhcp server doesn't sit on the same subnet as the end user that it needs to receive an IP address from, well, there's got to be some mechanism to steer that traffic to a destination where there is a Dhcp server located. So you're going to use what they call the helper address, the IP Dhcp helper address underneath the interface. Whether it's the logical subinterface, the logical switch virtual interface, or the physical interface, you're going to put the helper address, and that helper address is going to have IP reachability back to whatever Dhcp server you have configured, whether it's a router, a switch, a server, like an Active Directory server, or maybe you've got a boot P box somewhere. You're going to configure the relay agent to receive that broadcast discover packet and send that information on with the stream to the rest of the network. So that's going to be basically how you would go about doing that. One of the other options we have is the Dhcp options. These are what additional details, like your DNS server. Where does the IP phone download its configuration from? Is there a TFTP server? What type of information do you give different devices in the network? Do you give a Dhcp server information to add network time or something along those lines? Or an FTP server. There's lots of additional options that are available to you. I recommend you go check those out. What we're going to be taking a look at here is just a real simple instantiation of Dhcp. It's not going to be not very difficult in order to look at. But what I'm going to do is, in our configuration here, I'm going to do this on routers 4, 5, and 3 here on this LAN segment on R3, 4, and 5. I'm going to go ahead and pull that up. And what I'm going to do is, once I get this configured, I'm also going to be on Wireshark. I'm going to be taking a look at this. Go ahead and minimize this guy down here. Pull up GNS3. And on the connection for 5. Actually, I have to go to right here and start the capture. Actually, let me cancel. Let me stop the capture. Start the capture on the R5 port. Yep. Click OK. Give that a second to do its thing. So its Wireshark is being a little slow at the moment. We can go ahead and just close that out. Close the program. Okay. So we're going to go ahead and start the capture. And yep, and then we're going to go cancel. We're going to go ahead and start Wireshark. There we go. So now that that's capturing, what we're going to do is we're going to come in here and do a Dhcp or is it boot P? Boot P. Yeah, we're going to do boot P. And I'm going to go minimize this, or cancel. I'm going to minimize this for the time being, just so we can walk through the configuration here. And I'm going to say on this side here, I'm going to say debug IP DHCP and server, and we're going to hit the events. And events, and we're going to specify packet. Okay, and hit the enter key. We don't want to go super deep here, but what I'm going to do is I'm going to create a subnet, and there's two ways you can go about creating a DHCP server. You have the IP DHCP, and you have the pool. And the pool, if we were to name it, we'll say R3 underscore R5 through R5. We can do something along that, and then what I can do is I can either do a blanket /24, which means I can type in network of 10.1.100.0 255.255.255.0, or I can do a non-blanketed statement. I can go in here and state a host. So I can type in host. By specifying the host, I'm giving it a specific IP address. Now the way that I have this set up here, let me just double check here and do a do show run section Ospf. Let me see exactly how I have this configured. And I have... Okay, I must be creating it at the physical interface. So do show run interface fast 0/0 dot 100, and I am running it. Did I? I don't. Yeah, I do have the network command. So I'm doing it. With the network command here. I want to just make sure I'm doing that here. Do show IP Ospf interface brief. Interface is fast 0/0 dot. And this one is the interface. So I did do show run interface fast 0/0 dot 100 area 0. Okay. So what I basically did, and what I would have to be careful here on, is I could either use the host command or I could just do, the network command. I'm going to use the network command just to show you guys can see how this works. This is normally how you're going to deploy it on a router or a switch. You're going to type in network of 10.1.100.0/24. You're going to type in the default router is going to be 10.1.100.5. And that's pretty much all you have to do. So we go over here to our Wireshark capture. We won't see any data going back and forth yet because we actually haven't asked for it to happen. So we have our configuration in place. I'm going to actually come in here and type in the IP DHCP excluded address. The excluded address is going to prevent specific addresses from being allocated. So in this particular case, I have to type in 10.1.100.5. That's going to prevent the IP address of router 5 from getting allocated somewhere else. So now I'm going to go to R3, and I'm going to specify under interface fast Ethernet 0/0 dot 100. The IP address is going to be DHCP. So, and now the adjacency goes down, and then as soon as an address is allocated, we should see a log message for that. R5 should see information coming in, and whoops, R3 should say excellent. So now we have DHCP and address assigned fast Ethernet 0/0 dot 100 assigned DHCP address 10.1.100.1 to that guy, and then once that happens, once the address comes back up, we should have an adjacency on that connection. We go to router 4 and do it here as well. So So there, okay, and then now that we've done that, now our OSPF adjacency is back up. So going back to 4, we're going to type in interface fast ethernet 0/0 .100 IP address DHCP. So it goes to down, we go in there, and now we get the adjacency back up. We have we should get R5 should see some information going back and forth. We advertise .2, and we go to router 4. An IP address has been assigned. .2 is assigned. Our OSPF adjacency comes back up. Now if we go back over here to Wireshark, of course it wouldn't. Let's see. DHCP FO? I'm not sure if that's exactly what I'm looking for or not. Let me scroll down to the bottom real quick. We should see some information going back and forth here. Apparently not. Alright, well, that was lackluster. So what we have here on 5 is we have a couple of things going out. We have, for instance, we have a Dhcp Discover going out. The Dhcp Discover is somebody reaching out to us and saying, hey, I want to get an address for us. So basically the idea here is you have a connection where you go out, you want to reach a particular address, and you want to get that address, you go out there and you signal it. Now, when you go out and signal to a server that you want an address, you send out a discover message. There's a discover message. That message goes out and it looks for, it's an all broadcast, an all host broadcast, which is all 255s. It goes out to the Dhcp server. The first Dhcp server to respond is the guy that wins. Okay, so once you go out and you do a Dhcp Discover, you go out there and that's a broadcast. The second one is going to be the first server that responds to you is going to respond with an offer. The offer is, okay, here you go, here's the IP address that I've given you. Now this assumes that your local, the Dhcp server is on the same subnet as the router, as the host going after it. So if I go in here and do a do show IP OSPF neighbor, that is really weird. Why is it going? Oh, that's the way it's supposed to be. So what'll end up happening here is if I am on the same subnet as the client requesting the address, I'm going to go ahead and send an offer message back out to him saying, okay, here's the IP address that you're looking for. Now, if it works out to be where I happen to be giving them an address, and what ends up happening is whatever address you give them is what they're going to apply and whatever options you have configured, whether that's DNS, whether that's whether that's the default router. There's lots of other options that are available to it in order to get that operational. When the client receives that message, he's going to receive the offer back in. Now the offer and all the additional communication back and forth between the client and the server is all unicast. So what's going to end up happening is the receiver, the end station, is going to get an offer back in stating, here, this is the IP address that you asked for, this is what you're getting. When the client receives that, he's going to say, cool, thanks man, I appreciate it. Sends an offer back, or I'm sorry, a request back to the server saying, please go in and put a reservation in there, which means not to confuse that with the Dhcp reservation, but go ahead and reserve that IP for me. Make sure that nobody else can use that IP. So if that IP address is accidentally allocated to another station, what's going to end up happening is you're going to get a duplicate IP address notification. What's going to end up happening is that same IP is able to be reached via 2 different MAC addresses, and that's a bad sign. 2 MAC addresses, same IP, bad day. Now, there are instantiations inside of like a multicast for Anycast RP, We'll talk about that when we get into CCIE for multicast, where you can have the same IP address applied to a loopback interface of two different routers, and you're going to use the routing table to figure out which way to get there. There's a technique using Anycast RP with MSDP, and we'll talk about that in more detail when we get into CCIE. But we're going to do a short breakdown to multicast in case you guys have never dealt with it before. It's actually really easy to work with. What's going to end up happening is that request is going to go back and reserve that IP address for whatever the lease time frame is. The server is then going to respond with an acknowledgement and say, okay, you know what? Sure, I'll take that. You can have that IP address for X amount of time. So whatever information is given out in the DHCP information, that is what the client gets. Usually it's going to be DNS information, the default gateway, and that's pretty much about it. Normally you don't need to add any additional information. Now what's going to end up happening here is a additional piece, which is known as the relay agent. The relay agent, whenever you've got this deployed, which is more often than not, more environments that I work in have relays enabled because it doesn't make sense to have a DHCP server per subnet. It really doesn't. I could have a centralized DHCP server, typically per site, and I'm going to allow information to be able to talk to that relay agent as I go along. So let me go ahead and bring you guys to my, let's go take a look at it this way. Do show run section DHCP. Okay, so what I have here basically is a very, very, very rudimentary DHCP configuration. There's really nothing going on here. So one thing you're going to want to keep in the back of your mind is, and one thing you're probably asking is, how does the DHCP server know which pool to pull from when handing out DHCP addresses? And that's a great question. So since we're local here, R1 is local to R3 and R4, how does it know? Well, the only reason it knows is because of the default gateway, what they call the GIADDR, or the Gateway Interface Address. The GIADDR address is what helps the DHCP server determine which pool to pull from. So what ends up happening is you put an IP address on a physical interface, or you put an IP address on an interface, period. When a discover message comes in on that interface, that information is automatically going to be added to that DHCP request or discover, saying, okay, here I am, this is where I was received from. That's how the DHCP server understands what's going on in the back end. So that default router command that you see right there, the 10.1.100.5, that is going to be the identifier that the DHCP server pool uses to identify which individual DHCP pool to pull from. Now, okay, Rob, what happens if the subnet is not connected or on the same subnet as the DHCP server? I'm glad you asked. What ends up happening is the relay agent is going to be applied underneath the interface that has the default gateway IP address applied. What's going to end up happening is that GIADDR address is going to get filled with whatever address is applied to that interface that the helper address is applied under. So if it's VLAN 1 and you've got 10.1.1.1 applied under VLAN 1, you are going to send that information to the DHCP server, and the GIADDR address is going to have 10.1.1.1 in it. The DHCP server simply has to go look for any DHCP pool with the default router 10.1.1.1. He finds that, and he's going to know that either A, I'm going to be assigning this to a individual host, or B, I'm going to be applying one of many IP addresses to a collection of hosts that are on that subnet. Either one would be applicable assumptions. Then the offer request acknowledgement process comes into play, and that information is backtracked. Normally what's going to end up happening is you're going to be running into a helper situation. It just makes more sense that way. It's easier to deploy. It centralizes your DHCP and makes things much easier to work with. Now I know you're also thinking, okay, well how do I secure that? Because basically what's going to end up happening is I could run a cheap DCP server application or service on a desktop computer, and that will probably get a response quicker, or respond quicker, I should say, to a Discover message than some server that's either across the WAN or elsewhere. And your assumption would be 100% accurate. That's a very, very good call out. And to fix that problem, a technology or technique known as Dhcp Snooping came out. And basically, the objective of Dhcp Snooping is I have a particular instantiation of DHCP running. It runs wherever it's configured. Router, switch, firewall, doesn't matter. What ends up happening is that information comes in on the LAN. You get that all 255's broadcast because it doesn't know where else to send it. It gets that information, and my computer is running a Dcp server. I receive that information. If snooping is not enabled, then any interface that could potentially respond to a DHCP request does so. So my computer receives that discover, responds with an offer of an IP address, sets itself as the default gateway, and then proceeds on. Because if the DHCP server is local, the default gateway will be the DHCP server. But if the DHCP server is remote, so like in a data center somewhere, maybe you're running on a Active Directory server that might be physical or virtual, then it's going to be setting another IP address on another device as its default gateway. So I could set myself as the default gateway. So here I am the exit path to the network. Go ahead and use me. So that means everybody in the network would point themselves to this my computer on the LAN. And then from there, we're going to go ahead and the individual host, my computer that's running the DHCP server, would have a static route that says, you know what, go ahead and send anything I don't know about to the actual default gateway. So then I simply have everybody send their traffic to me. Do you see a potential problem there? I do. It's called a man in the middle. I could simply capture all of the data on the LAN and see what's going on, and I can sit there and watch anything that is not encrypted or heavily authenticated, and I could take a look at it, and if I have the time, decrypt it and figure out, usernames, passwords, traffic flows, all kinds of stuff. So it's going to give me a lot of flexibility in that regard. Dhcp snooping is designed to be enabled on a particular VLAN, whether it's a router or a switch, and then when it's deployed on a switch, you are going to specify which individual interfaces a DHCP server is reachable from. So if you have to go up to a router that's got to go to another switch, to a router, to another switch router combination in order to get to the DHCP server, then any interface that connects you to the DHCP server needs to be trusted. If you do not trust that interface, then any responses, so any offers back from the DHCP server, are going to be dropped because it hasn't been trusted to do so. That's going to be the basic way of doing that, and that's what they call Dhcp snooping. It's usually coupled with another security feature called dynamic Arp Inspection, and relatively easy to work with for the most part, but definitely needs to be understood from the perspective of what it's trying to accomplish. But that's basically the idea behind it. So that's the big caveat when it comes to understanding how DHCP works. There's not a ton that, I shouldn't say it that way. There's a ton of options that are available to you when you're running DHCP, but knowing what the network is doing operationally is going to be huge. So if you understand that, high five, nice job. You're well on your way to understanding how DHCP works. We'll take a deeper look at CCIE simply for the fact that in this instantiation, it was supposed to be pretty rudimentary because they're asking you more or less, how does DHCP work? So knowing more of the theory is definitely going to help you out. Long term, there are additional capabilities. You can set different parameters and stuff like that. We'll take a look at a deeper dive in the CCIE course that's going to be coming out here very soon. Stay tuned for that. But beyond that, from a DHCP perspective, that's really it. Now, one of the things that I wanted to show you guys before I left off was a show control dash plane host open ports. One of the things that ends up happening whenever you create a DCP server is you end up opening yourself up to, you have to end up opening ports for communication. So the server is .67 and port 67. The client is, in this particular case, 3. If we were to come out of here and do a show control plane host open ports. In this particular case, it doesn't show it to you because of the configuration, but we would be listening on port 68. So 67 is the server, 68 is the client. I go out there and I request any information. I get a response back in from the server. The communication going back and forth is that. So typically speaking, the lower port number is going to be the server, but not always. So just keep that in the back of your mind. That's pretty much it, folks. Until next time, you guys take it easy.